Welcome to section 6.2, Adding and Subtracting Rational Expressions for Math 95. Our goals in this section are going to be to find the least common denominator of rational expressions and then use that to add or subtract rational expressions. Adding and subtracting rational expressions is an awful lot like adding and subtracting rational numbers, that is, fractions. So throughout this section, we're going to start each topic with a review of fractions, and then do some examples with rational expressions, and then I'll have a couple of examples for you to try. So let's go ahead and get started on our first fraction example, which is adding and subtracting fractions that have the same denominator. You may remember from your previous work with fractions that in order to add two fractions, you need to have the same denominator. Essentially, this is because when we add and subtract, we need to add or subtract like things, apples to apples or oranges to oranges. The denominator of a fraction tells us what type of thing we have, whether it's a half, a third, a fourth, and the top tells us how many of those things we have. For instance, here I have 3/15 plus 2/15. You can think of the 15 as the type of thing. That's the size of the piece of pie that I'm adding, and I have 3 of them plus another 2 of them for a total of 5/15. Notice that I only added the numerators together and I didn't add the denominators, since that's really just telling me what type of thing I have. Now you may be looking at 5/15 and thinking that that can be reduced, and it can be. 5 goes into 5 one time and into 15 3 times. In other words, 5 slices of a 15th each is the same as one slice that's a third of the whole pie. So long story short, when I have fractions with the same denominator, I can add the numerators and then leave the denominator alone. Once I get to my final answer, I should take a look at it and see if it's possible to reduce it at all. Now let's take a look at the second example. I have 5/7 minus 3/7. We already have the same denominator. I've got 5/7 and I'm taking away 3 of them, so that gives me a total of 2/7. And this is a fraction that cannot be reduced, since 2 and 7 don't have any common factors. Just like with rational numbers, as long as we're starting with common denominators, adding and subtracting rational expressions is pretty straightforward. We just have to be a little careful when we're subtracting. For example, here I have x over 6 plus 7x over 6. These guys have the same denominator, so I just need to add my two numerators together, giving me x plus 7x over 6. And then I notice, hey, x and 7x can actually be combined since they're like terms, which gives me 8x over 6. Finally, this fraction can be reduced. 2 goes into 8 4 times and into 6 3 times, making this 4x over 3 as my final answer. For my second example, I have a over 5b cubed minus a plus 2 over 5b cubed. So again, we have the same denominator. But this is one of those problems where we need to be a little bit careful about the subtraction. So for my numerator, I'm going to have a minus the numerator of my second fraction. So I want to minus the whole thing, the whole a plus 2. My denominator stays the same. The reason that this is important, these parentheses here, is that in my final answer, I'm going to end up with a minus 2, not a plus 2, since I'm subtracting it, all over 5b cubed. Of course, I'm not quite done yet, since I see that I have some like terms that I can combine. A minus a is 0 a's, actually, so I'm left with just a negative 2 on top and a 5b cubed on the bottom. So subtracting isn't so tricky. You just need to make sure that the negative gets distributed to all the parts of the numerator. Next up, I've got x squared over x plus 3 minus 9 over x plus 3. Again, same thing in the denominators, so we're ready to do the subtraction. It ends up being x squared minus 9 on top and x plus 3 on the bottom. It doesn't immediately look like this has anything in common, but notice that we can factor the numerator. X squared minus 9 is a difference of squares, so this factors as x plus 3, x minus 3, all over x plus 3. Do you see now that we can cancel an x plus 3 from top and bottom? That leaves us with an x minus 3 on top. Now we can write this x minus 3 over 1, but since dividing by 1 just leaves the thing the way it is, this is the same as just x minus 3. So again, if you're adding and subtracting fractions that already have the same denominator, you'll just add or subtract the numerators, and then see if you can do any simplifying at the end. And now here's a couple problems for you to try. Go ahead and pause the video, give these problems a shot, and then we'll come back and talk about them together. And we're back. Let's go ahead and look at these problems together. In my first example, I'm adding two fractions together that already have the same denominator of 3x cubed, so I know that my denominator will also be 3x cubed. Since I'm adding, I will add the numerators straight across. X squared plus 1 plus x plus 2. Now I'll combine like terms as much as I can, which gives me x squared, a single x, and then a 3, all over my denominator of 3x. Now I should look at my answer and see if it's possible to simplify it. That is, look to see if there are any common factors between the numerator and the denominator. I noticed two things. First, even if I factored x squared plus x plus 3, I wouldn't get a single 3 or a single x out to be able to cancel. So I'm probably not going to be able to cancel anything here. The second thing that I notice is that x squared plus x plus 3 is actually a prime polynomial. There's no way to factor it, since there are no two things that multiply together to be 3, but add together to be positive 1. So this top polynomial actually won't factor at all, so I'm very confident that this is my final answer and that it's as simplified as possible. Now let's look at this second example. Here I'm being asked to subtract two fractions where they have the same denominator of x plus 2. So I know right away that my denominator will be x plus 2, and then I'll be subtracting the numerators. That means I'll have 4x minus this whole numerator, x minus 5. Don't forget to distribute that negative sign to both pieces of the numerator. That gives me 4x minus x plus 5. Now, I believe that you could go straight from this step to this step if you feel confident. Just don't forget about that sneaky negative sign. Now that I've got 4x minus x plus 5 on top, I'm going to see if I can combine any like terms. 4x minus x is 3x, and I've still got a plus 5. Once again, I pause and look at my answer to see if there's any way that I could factor something out and maybe cancel something top and bottom. But there's nothing in common between 3x and 5. And there's also nothing in common between x and 2. So both the top and the bottom are as factored as they can be, which means that there's nothing left to cancel, and it can't be simplified anymore. Now that we've taken a look at how to add and subtract fractions that have the same denominator, we need to go back and take a look at what happens when they don't have the same denominator. That is, we need to talk about finding the least common denominator. Again, we're going to start by doing a review with fractions, and then doing some examples with rational expressions, and then I'll have a couple problems for you to try. My first pair of fractions is 1/2 and 1/3. For the least common denominator, I'm looking for a number that both 2 and 3 will go into. Because these numbers are pretty small, you may have been able to realize already that the least common denominator is 6, since that's a number that both 2 and 3 will go into. My second example is 1/24 and 5/36. This time we're looking for a number that both 24 and 36 will go into. These numbers are a little bigger, and it may not be immediately obvious what the least common denominator should be. This is when we employ a factor tree. I'm going to factor both 24 and 36 into their prime factorization. I'll start with 24. I notice that it's divisible by 2, which leaves me with a 12. 2 is also divisible by 2, leaving me with a 6. 6 is divisible by 2, which leaves me with a 3. Now we'll go ahead and do the same thing for 36. Again, divisible by 2, leaving me with an 18. Again, divisible by 2, but this time leaving me with 9, which is the same as 3 times 3. What these factor trees show me is that 24 is made up of 3 2's and 1 3, while 36 is made up of 2 2's and 2 3. What I want to do now is write down a number that has all the parts necessary to make either a 24 or a 36. Now, in order to make up a 24, I need 3 2's and 1 3. To make a 36, I need 2 2's and 2 3's. I already have the 2 2's and 1 of the 3's, so I just need one more 3 to complete this thing. When I multiply this number all together, I see that it is actually the number 72. 72 is my least common denominator for 1/24 and 5/36. Now, finding the least common denominator is swell, but ultimately we need to be able to rewrite these fractions so that they have the same denominator. We do this with the creative use of multiplying by 1. Let's start by looking at 1/2 and 1/3. We already know that the least common denominator for these two is 6. So now what I need to do is build up each fraction to have the same denominator, 6. Now, looking at the number 1/2, and knowing that I need to end up with a 6 in the denominator, what do you need to do to a 2 to get a 6? Or what do you need to multiply 2 by to get 6? You've probably already seen that that is 3. So we're going to be multiplying by 3. But if I do that to the bottom of a fraction, I need to do the same thing to the top of the fraction. 1 times 3 is 3, and 2 times 3 is 6. Notice that I multiplied 1/2 by 3 over 3. 3 over 3 is really 1, since 3 divided by 3 is the number 1. And when you multiply a number by 1, you don't actually change its value at all. Notice that when I multiplied 1/2 by 3 over 3, I got 3 over 6, which reduces back down to 1/2. We haven't really changed anything fundamental. We've only changed the way that the fraction looks. Now we can do the same thing with 1/3. I start with 1/3. I want to get to the least common denominator of 6. I need to multiply the 3 by 2 to make that happen. But I have to do the same thing to the top so that I'm not actually changing anything. Now when I multiply across, 1 times 2 is 2, and 3 times 2 is 6. Again, notice that 2 over 6 is the same number as 1 over 3. We haven't fundamentally changed anything. We've just changed how it looks. So now we've rewritten our two fractions to have the same denominator. 1/2 is the same as 3 over 6, and 1/3 is the same as 2 over 6. Now let's do the same thing for our 1 over 24 and our 5 over 36. Remember that we found the LCD to be 72, so that's my goal denominator. Write down 1 over 24. My goal over here is to get a denominator of 72. What do I need to multiply 24 by to get 72? That may not be something that you know off the top of your head, but you can grab your calculator and do some experiments and find that if you multiply 24 by 3, you'll get 72. Of course, if I do that to the bottom, I got to do the same thing to the top. 1 multiplied by 3 is 3. 24 multiplied by 3 is 72. Now let's do our 5/36. I write down my 5/36. Off to the side, I know that I'm aiming for a denominator of 72, and I've figured out that 36 multiplied by 2 will give me 72. But whatever I do to the bottom, I have to do to the top. Now I've got 5 times 2 is 10, 36 times 2 is 72. So here are my two new fractions with the same denominators. Finally, let's bring this thing all the way around. I'd like to add these fractions, 1/2 plus 1/3. Now we just learned that 1/2 is the same as 3 over 6, and 1/3 is the same as 2 over 6. Now these are fractions with the same denominator, and I can add their numerator straight across. 3 plus 2 is 5, and the denominator stays the same, 5/6. To add 1 over 24 and 5 over 36, it's the same thing. I start by rewriting my 1 over 24 as 3 over 72, and my 5 over 36 as 10 over 72. Then I add the numerators. 3 plus 10 is 13, and my denominator stays the same, 72. We just had a reminder of how to take two fractions and build them up so that they have the same denominator, so that we can add or subtract them. Now we're going to expand that same idea to rational expressions. The first thing that I want to do is remember what we did with the numbers to find the least common denominator. Here's finding the least common denominator in my words. We take our denominators and we factor each of them. Then we write down an expression that contains the factors or the building blocks for each denominator. We can do the same thing with our rational expressions, and actually it's almost a little bit easier than it is with the numbers. Let's start with 4 over x to the 4th and 1 over 4x squared. We're going to find the least common denominator for this pair of rational expressions. I'm going to start by going a little bit overboard and writing down the complete factorization for each of my denominators. I have 11x to the 4th, which is the same as 11 times x times x times x times x. I also have a 4x squared, which is the same as 2 times 2 times x times x. Now I need to write down an expression that contains the building blocks for each of these two denominators. From my first one, I need an 11 and I need 4 x's. To make up my second denominator, I need 2 2's and 2 x's. I already have the 2 x's, but I'm missing the 2 2's. Now I've got them added on there. My final step is going to be to condense this back down to something a little bit prettier. 11 times 2 times 2 is 44, and x times x times x times x is x to the 4th. There are two things that I want to point out about this example. First is that if we hadn't had any x's, we still would have ended up with 44 for our least common denominator, just using the same process of factoring each denominator and then writing an expression that contains all the factors that we need. Finding the least common denominator for the number part isn't actually a new skill for you, though it might be one that you're a little rusty on. Secondly, I want to point out that I didn't really need to write down all of these x's to see that I was going to need an x to the 4th as part of my least common denominator. My first fraction had an x to the fourth in it, so I knew that I was going to need at least 4 x's. My second fraction had an x squared, so I knew that I was already covered. I needed 2 x's for it, but I'd already figured out that I needed 4 x's from the first one. Whatever the highest power is on a particular variable between your denominators is going to be the power that you end up with on that variable in your least common denominator. So here I had an x to the fourth and an x squared. 4 is the highest power, so I know I'm going to end up with an x to the fourth in my least common denominator. So finally, my least common denominator here is 44x to the fourth. Now let's take a look at my second example. I'd like to find the least common denominator for x over x squared minus 7x plus 6 and x plus 4 over 3x squared minus 2x minus 1. The steps for finding the least common denominator are the same here. We're going to start by factoring each denominator. It's just that this time we're going to have to use our techniques for factoring trinomials in order to factor these denominators. Hopefully you're feeling pretty comfortable with factoring now. So I'm going to sort of fast forward through that part so that we can get to the new material in this section. However, if you find that it's going too fast, remember, you can pause the video and you can always ask questions when you come to class. So now, using the magic of television, we'll fast forward to where we factored these two denominators. My first denominator factored as x minus 1, x minus 6, and my second denominator factored as 3x plus 1, x minus 1. Now that I've factored each of my denominators, I'm going to write down the least common denominator by writing down an expression that has the factors that are needed to make up each denominator. I start by looking at my first denominator. It requires an x minus 1 and an x minus 6. My second denominator requires a 3x plus 1 and an x minus 1. I already have the x minus 1 part, so I don't need to repeat that. But I don't have the 3x plus 1 part, so I'll need to add that in. That means that my least common denominator for these two rational expressions is x minus 1, x minus 6, 3x plus 1. Two things to notice. You do not need to multiply this back out. In fact, it'll be easier for you later if you leave it factored out the way that it is. Second thing to notice is that it doesn't matter which order these factors are written in. I happened to write x minus 1, x minus 6, 3x plus 1. I could just as easily have written x minus 6, x minus 1, 3x plus 1, or 3x plus 1, x minus 1, x minus 6, or any other combination. As long as you've got all three factors in there, you've got the least common denominator. You didn't think I'd let you keep going without trying a couple of these problems on your own, did you? Here are two pairs of rational expressions for you to try finding the least common denominator of. Notice on this guy, x squared minus 36, that you have a difference of squares that you can factor. Go ahead and pause the video, find the least common denominator, and then play the video up when you're ready to talk about these problems together. And we're back. Let's look at this first problem together. My two denominators were 2y squared, 7y. So I went ahead and noticed that because of the 2 and the 7, I'll need a 2 and a 7 in my least common denominator. And because of the y squared, I'll need at least a y squared. Because this one has just a single y, I don't need any more y's, since I already have it covered with the y squared, making my final least common denominator 14y squared. For a slightly more visual idea of why I end up with y squared, I might go ahead and factor this thing completely, writing it as 2 times y, and then thinking of 7y as 7 times y. Now I'm going to write down all the pieces that I need for each denominator. My first denominator needs a 2 and 2 y's. My second denominator needs a 7 and a single y. I already have a single y, so all I need to do is add on a 7. And notice that I end up in the same place at the end, 14y squared. My second example had a little more work up front with the factoring. I take my two denominators and I factor them as much as I can. My first denominator is a difference of squares and factors as x plus 6, x minus 6. My second denominator factored as x plus 6, x plus 3. To write down my least common denominator, I'm going to write down the factors that I need in order to make up each of these denominators. So first, I will need an x plus 6 and an x minus 6 to make up the first one. My second denominator is made up of x plus 6 and x plus 3. I already had an x plus 6, so I don't need to write that one down again, but I do need to tack on an x plus 3. My least common denominator then is these three factors all strung together. Before we move on, make a note of these least common denominators because in the next several slides I'm going to ask you to add or subtract these fractions, and it'll be handy to already have your least common denominator written down. Earlier in this video, we reviewed how to find the least common denominator for some fractions, and then we built up each fraction to have the same denominator, ultimately so that we could add or subtract them. That's what we're going to do now. We're going to take these pairs of rational expressions and build them up so that they have the same denominator. Notice that these are actually two pairs of fractions that we already saw earlier in the video. We've already found the least common denominator for these pairs of fractions. For my first pair of fractions, the least common denominator is 44x to the fourth. Now I'm going to work on building up each fraction to have that as the denominator. We're going to do this just the same way that we did with the numbers. I start with my original fraction, 4 over 11x to the fourth. And I know that my goal denominator is 44x to the fourth. What do I need to multiply 11x to the fourth by to get a 44x to the fourth? Hopefully you're thinking it's just 4. So I'll multiply by 4 on the bottom, but I've got to do the same thing to the top so that I don't change the value of my fraction. Now multiplying across, 4 times 4 is 16, and I can double check. 11x to the fourth multiplied by 4 is indeed 44x to the fourth. Now I'll look at my second fraction. My original was 1 over 4x squared, and my goal denominator is still 44x to the fourth. Now what do I need to multiply 4x squared by to get 44x to the fourth? First I notice that I'm going to need an 11, since 4 times 11 will give me the 44. Then I have an x squared, but I need an x to the fourth, which means I need 2 more x's, or another x squared. And then again, whatever you do to the bottom, you've got to do to the top of the fraction to keep things balanced. Now I multiply straight across, giving me 11x squared on the numerator, and 44x to the fourth on my denominator. Notice that if I simplified either of these two fractions, I would get back to the fractions that I started with. That's actually our goal. We're trying to unsimplify these fractions so that they have the same denominator, so that ultimately we'll be able to add them together. Now let's take a look at this second example. It's going to really help us if we've already factored the denominators. So I'm going to go ahead and do that really quick. Remember that we actually did this factoring a little bit earlier. And earlier we also found that the least common denominator was x minus 1, x minus 6, 3x plus 1. So again, I'm going to work on building up each of my fractions to have this as the denominator. So I start by looking at my original fraction, x over x minus 1, x minus 6, and I think, what do I need to multiply this by to get this thing over here? Well, it's only missing one piece. It's only missing the 3x plus 1. So I multiply by 3x plus 1. But whatever you do to the bottom, you got to do to the top of the fraction to keep it balanced. So I'll multiply across here and get x times 3x plus 1 as my new numerator. Now we'll go ahead and do the same thing for our second fraction. I have x plus 4 on top, 3x plus 1, x minus 1 on the bottom. My goal denominator is x minus 1, x minus 6, 3x plus 1. Now I notice that I already have the 3x plus 1 and the x minus 1 part, but I don't have the x minus 6 part. So I'm going to multiply top and bottom by x minus 6. When I pull that over, I have x plus 4 multiplied by x minus 6 as my new numerator. Once again, I'm going to ask you to notice that if I simplified these rational expressions by canceling like terms, I would get back to the rational expression that I started with, and that's good. Do you remember how I asked you to make a note of those least common denominators that you found earlier? Well, I hope you did, because now I'm going to ask you to rewrite each of these pairs of fractions so that they have the same denominator. You've already done the work of factoring and finding the least common denominator. All you're going to do now is build these guys up to have the same denominator. So go ahead and pause the video, write these guys down with the same denominator, and when you're ready, play the video back up and we'll look at them together. And we're back. Let's go ahead and look at these two problems together. My task here is to rewrite each fraction so that they have the same denominator. For my first pair, I already found that the least common denominator was 14y squared. So I take my first fraction, 5 over 2y squared, and I write down my goal denominator over here on the right, 14y squared. Now I think, what do I have to multiply 2y squared by to get a 14y squared? The answer is 7, so I have to do the same to the top. 5 times 7 is 35. 2y squared times 7 is 14y squared. Now I grab my second fraction, 2 over 7y, and I ask myself the same question. What do I have to do to 7y to get 14y squared? Now to get the 7 to turn into a 14, I'll need a 2. And to take a single y and turn it into a y squared, I'll need another y. I multiply top and bottom by the same thing, which gives me 4y as the numerator. Now let's look at this second example. I started by writing down my two fractions with their denominators completely factored. I had x plus 2 on top, and then x plus 6, x minus 6, and my second fraction was x with an x plus 6, x plus 3 on the bottom. And then I remembered that we'd already found the least common denominator to be x plus 6, x minus 6, x plus 3. So I wrote down my goal denominator here. Then I looked back at my original fraction to see what I would need to multiply it by to get to my goal denominator. It looks like all it's missing is the x plus 3. So I tack an x plus 3 onto the bottom and also do the same thing to the top. Notice that when I multiply across, I keep my x plus 2 in parentheses and my x plus 3 in parentheses, so that when I do ultimately multiply these out, I'll have to FOIL. I don't want to forget that I need to FOIL when I multiply these out. For my second fraction, I do the same process. I write down my goal denominator, and then notice that it's missing the x minus 6 factor. So I multiply both top and bottom by x minus 6, leaving me x times x minus 6 as my new numerator. So far, we've seen how to find the least common denominator for some rational expressions, and then how to build up each rational expression to have the same denominator. Now we're going to get to the whole big point of it all, which is to add or subtract those rational expressions. Notice that we're coming back to these same examples that we've been working with this whole time. I'm going to work on adding 4 over 11x to the 4th plus 1 over 4x squared. Now earlier, I found that the least common denominator here was 44x to the 4th. And then we built up each of these fractions to have that denominator, and found that this was the same as 16 over 44x to the 4th plus 11x squared over 44x to the 4th. Now we're back to those very first examples. These two have the same denominator, so I can just add the numerators, making this 16 plus 11x squared over 44x to the 4th. Before I put a box around my answer, I'm going to take a quick look and see if it would be possible to simplify this rational expression. I look at 16 plus 11x squared, and I notice that they don't have anything in common, and it's not a difference of squares. So I can't factor the numerator. Denominator's already factored, it's just one term. So there's nothing more that I can factor here in order to simplify. So this must be my final answer. My second question is asking me to subtract these two expressions. Now remember, I already found that the least common denominator for these two was x minus 1, x minus 6, 3x plus 1. And we already rewrote them to have that same denominator. So we can use that work that we've already done. This fraction is the same as x multiplied by 3x plus 1 all over my least common denominator, x minus 1, x minus 6, 3x plus 1. And then I'm subtracting x plus 4 multiplied by x minus 6 all over x minus 1, x minus 6, 3x plus 1. And again, remember, we found this earlier. At this point, there's sort of two ways that we could go. I know that ultimately I'm going to be taking this numerator minus this numerator and writing it all over my least common denominator. However, I also see that I'm going to need to multiply these numerators out at some point so that I can combine like terms to get my final answer. I'm going to go ahead and do that part right now, but I'm going to do it kind of quickly, so you may want to pause the video and try doing it yourself. There they are, my nice numerators all multiplied out. Now I can take numerator 1, 3x squared plus x, and subtract my second numerator. Remember that that negative needs to be applied to all three terms, which will make this minus x squared plus 2x plus 24, all over my same common denominator, x minus 1, x minus 6, 3x plus 1. At this point, we've done the subtraction. All we need to do now is simplify as much as we can by combining like terms on my numerator and then factoring the numerator and seeing if we can possibly cancel anything from the denominator. So I start combining like terms on my numerator and I get, let's see, 3x squared minus x squared is 2x squared. I've got an x and another 2x for a total of 3 x's and a plus 24. All over my least common denominator, x minus 1, x minus 6, 3x plus 1. At this point, I want to try factoring my numerator just in case I might be able to cancel something from the denominator. However, if you start trying to factor this, you're going to notice, if you use the a times c method, that you're looking for numbers that multiply to 48 but add to 3. And there just aren't any numbers like that. My numerator is prime, so I can be really confident that this is my final answer and it can't be simplified anymore. Before we go, why don't you try adding or subtracting the two expressions that you've been working with this whole time? Remember, you've already found the least common denominator and you've already built those two fractions up to have the same denominator. Now you're just going to put on the final touches and do that addition or subtraction. Go ahead and pause the video while you try that, and then we'll come back together and see how it went. And we're back. Remember that you already built these fractions up to have the same denominator. You got 35 over 14y squared minus 4y over 14y squared. Because they have the same denominator, all we need to do now is subtract the numerators, giving us 35 minus 4y all over that common denominator of 14y squared. Notice that the two terms in the numerator don't have anything in common, and they're not a difference of squares, so this certainly can't be simplified any further, and is our final answer. On this second problem, again, remember that you already built these fractions up to have the same denominator. So all we have to do to start with is write down what those fractions were. When we built up the first fraction, we got x plus 2 times x plus 3 all over the least common denominator. And for my second fraction, I got x times x minus 6 all over my least common denominator. Now I decided to go ahead and multiply the numerators out before I did the addition, but you could really do this either way. So for my first fraction, I have an x squared plus 5x plus 6 in the numerator, and then an x squared minus 6x in the numerator of my second fraction. Then I go ahead and do this addition. They already have the same denominator, so all I need to do is add the numerators, which gives me x squared plus 5x plus 6 plus x squared minus 6x. Then I combine like terms, giving me 2x squared minus x plus 6. This does not factor, which means that there's nothing more we can do to try to simplify this. This is my final answer. What we just did through the course of this video was find the steps for adding or subtracting rational expressions, and then we worked with a couple particular examples and worked through those steps really carefully, one at a time. Here are the steps as a list. If you're adding or subtracting two rational expressions, your first step is to factor the denominators and find the least common denominator. Then build up each rational expression to have the same least common denominator. Finally, add or subtract the numerators, keeping the common denominator. And if you can, simplify what you get at the end. These problems can take up a lot of space when you're working them out. That's okay. It's worth it to use as much space as you need to keep your work organized so that you don't miss. We're going to end part 1 of the section 6.2 video here. Part 2 has several worked out examples, so you'll want to watch that to see how all these pieces fit together and get some ideas for how you might want to organize your work.